Hello, I'm Nicholas Taubert, and this is my Turing machine designed to calculate a Blizzard Sorceress build for Diablo 2 based on user input and with the capability of handling repeatability and disorder. Now, this is what the vision for Workshop 3 is. This time, the machine would run as an external application attached to an interface. There would be a starting menu screen where the user can select to have the machine auto build the best possible build for their level, and it would attach to Diablo 2 windows automatically, or choose to enter their own theoretical build in any order. They can only enter the values of interest and can ignore the rest. And the reason why I explained a little later on is in the planning stages, I was unsure exactly what information would not be necessary. But after selecting either one, the user would then be taken to a main menu screen with an attached output box, and the user could select any of the first 5 options and see the result in the output box. They could even select the same option twice, as seen in this example. They could calculate stamina, then health, and stamina again if they so pleased. The user could also click New Build, sending them back to the starting menu to make a new build either through auto generation or by hand in a custom build. Finally, when the user is finished, they can click Exit to close the program. Notably, this machine doesn't perform any calculations itself. It outputs the arithmetic in a form that can be easily copied and pasted into a web-based calculator such as Google or Desmos. If calculating damage, all addition must be done before multiplication, which it says in the output. Um, So this requires a Turing machine to do, as this could calculate several things using any combination of the same things, whereas a PDA must calculate them in order of the stack and loses them once they're popped off the stack. Even if we were to add several points for each operation, such as adding 3 Bs to the stack for every 1 point allocated to Blizzard so that it could be calculated and popped off 3 times, we still wouldn't be able to access the items below those Blizzard's allocations in the stack until every one of them was popped off. So therefore, this is not a context-free language. Um, I'm very glad I've been able to keep to the same theme throughout the development of each workshop because it allows for clear comparison between the capabilities of each machine. After completing Workshop 3, the JFlap for Workshop 1 is almost humorously simple. I don't have enough time to completely review Workshop 1 and 2, so all you really need to know is that Workshop 1 was centered on the machine building the Blizzard Sorceress build for any given level, and that Workshop 2 focused on calculating the values related to that build by outputting them into the Diablo 2 chat box. This also took calculating the damage for Blizzard, which was really complex and involved a lot of math for how much it increases based on how many levels are already put into it and the synergies that multiply that value and all that jazz. All right, so along with the ability to work with user input, I also wanted to add a few more options for the user to choose from, such as the ability to calculate mana, stamina, and the damage dealt by Ice Blast. So to start, I had to figure out how to get the numbers for the attribute-based stats. Because each attribute stat increases by a little every level, and for every point placed into the related attribute, I had to figure out how to do both. So to do so, the level is configured in a backwards manner by adding 1/5 of the amount awarded per level to every attribute point, since 5 attribute points are awarded per level. That added to the 1 or 2 points per attribute point allocated to a certain attribute give the values shown at the bottom here. That sounds really confusing. It's a lot of weird words. Basically, like life is increased by 2.2 for every point in vitality, or 0.2 for every point in any other attribute. Stamina is increased by 1.2 or 0.2, and mana is increased by 2.4 or 0.4. These next 2 slides show the numbers for calculating Blizzard. I actually calculated all this during Workshop 2, so I'm just going to skim by pretty fast. But basically, the amount by which the damage of Blizzard increases per level, it increases in linear amounts, but that the slope of that line changes to level 8 and level 16 of Blizzard. But then every point past level 16 is the same. Additionally, Blizzard has synergy spells, which increases its damage by 5% for every point in those spells being Ice Bolt, Ice Blast, Glacial Spike, and Cold Mastery. These are the exact values for the calculations of Blizzard at each stage. This takes 16 sets of states to do so that we can keep track of how many points have already been put into Blizzard at any given point, but we'll get into that. We'll get further into that later. So, at first I thought it would be useful to calculate the damage for not only Blizzard, but also the other important cold spells, such as Ice Bolt, Ice Blast, and Glacial Spike. I elected to remove the ability to calculate damage for a couple of the cold spells early on, though, and eventually narrowed it down to just 2. So Ice Bolt is a starter spell and is objectively worse than Ice Blast in damage and can only apply slowness instead of actually freezing the enemy, and is therefore only invested in 2 for points due to its synergies with other spells like Blizzard. Frost Nova does barely any damage even at its max level, and it's primarily intended to slow enemies instead of damaging them. But because Blizzard does monumentally more damage and can freeze enemies instead of just slowing, and because Frost Nova only really gives energy to Ice Bolt, it becomes obsolete. Later on in the project, I actually removed the ability to calculate damage for Frozen Orb and Glacial Spike as well. Frozen Orb is an AoE attack without many synergies to assist damage and is therefore completely outmatched by Blizzard in every way. Glacial Spike is almost identical to Ice Blast, except that it receives about 3% less damage from synergies than Ice Blast, so it is almost never used, as Ice Blast is strictly better. This leaves us with only 2 damage values worth calculating: Blizzard and Ice Blast. Blizzard is optimal for large groups, but Ice Blast will actually do the most damage to single targets, such as solo bosses. Thankfully, due to the nature of Ice Blast and its damage coming from mostly synergies, and thanks to its pretty linear progression, we were able to calculate it without having to remember how many points have already been put into it, unlike Blizzard. We won't count Glacial Spike as a synergy for this since it doesn't affect damage but freeze duration. However, we will count Cold Mastery as a synergy because its effect is that it increases cold spells passively by the same amount that a synergy would. So in this workshop, I still have the ability to automatically configure the best skill and attribute allocation at the very beginning if the player chooses to do this. This would be represented by a starting character of a capital A, which indicates that the machine will then go through each skill in order to see if those skills can be taken, usually taking as many of those skills as possible, and doing the same with the attribute points. In this case, it would be assumed that the machine responds to these inputs that are represented by characters in the actual form of succeeding or failing to allocate points. Because of this, I designed the state machine to visually represent the machine most accurately. The machine would simply read each input as a success or failure and would write to the tape the skills and attributes that are allocated accordingly. However, there is another option as well now. Users may input their own string of combinations to represent their unique Blizzard Sorceress build by entering information regarding which skills and attributes they have put points into and how many. This also allows players to enter points into anything that may have come passively from gear. This machine can only handle inputs regarding skills important to Blizzard Sorceress builds. Points placed in like fire or electric builds are irrelevant to any of these calculations and therefore can be ignored while entering the points. If the user decides to do this, the machine does not process through states in the form of successes and failures to translate. Oh, yeah. The machine doesn't. If the user decides to put in their own string, then instead of going through in the form of successes and failures, instead the machine already has a string that's, for the purpose of this JFlap, going to take the form of the initial tape. Now the machine is divided in 2 separate primary regions: the starting menu and the main menu. And the initial tape is similarly divided into the build itself and then what to do with that build. Again, the first chunk of the input will initially start with either a capital A or a money sign and will end with a hashtag. In between, it may be filled with a series of S's, F's, and O's, which are to be converted into 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, or whatever. Or the user may input a string themselves, in which case it would be good to go with a combination of numbers already. In the second chunk, the machine processes these characters that would represent a user's input and what they would like to be calculated. The user can choose to calculate base health, mana, stamina, or damage per second of Blizzard or Ice Blast. These can then these commands can be chosen in any order, can be repeated, and the user can even choose to delete the current build and add a new one, or have the machine auto build the best one for the current level, as indicated by the note at the bottom. The end of the entire string, like the entire even redo deletes, is signaled by a capital Q, which will close the program. These take the form of capital letters and the hashtag, and each of these commands will be converted into like lowercase x's after they're read, so that the machine knows they've already been processed and they don't have to be processed again. So here's a more formal description of the language that might help these two distinct parts make more sense. So the first chunk can come from either L1 or L2. L1 if the user chooses to let the machine automatically make the build for them, and L2 if the user wants to input a custom build. In the case that L1 is chosen, the machine actually responds to signals when it tries to put points into a skill or attribute. If S if it's a success, F if it's a fail but points still remain, and O if it's a fail and no skill points remain. And translates this into a string that could be produced by L2, except for the F's and O's will still remain. L2 shows that in order only matters when the machine has to use S's to convert into, because it has to know where the S's kind of are in the machine, like where it's sitting. But because L2 they're putting it in themselves, they can put it in any order, and then the skill and attribute allocations can be calculated in any order, which is something that a push-down automaton can never do. Here's the first half of the input alphabet definitions. You'll notice that C and D were removed from the last workshop because the actual meaning of the symbol no longer has to be specific. The machine just has to know what to translate that character into based on the position of the state and the machine that the machine is currently on. But yeah, S, F, and O are just there to represent what the machine would read as it went through the automatic process. 0 through 8 are what it either starts with or translates S's into and represent each allocated point. On the next slide, we'll see the rest. You'll notice that the top is now labeled tape alphabet instead of input alphabet. The tape and input alphabet are nearly identical, with the one exception being the X at the bottom, which represents commands that have already been processed, so the machine knows they don't have to be done again. All these letters represent different commands the user can give to the machine to compute in any order and combination, any number of them. The money sign and hashtag just show the machine where the build starts and stops. Now, why don't I have characters for every sorceress skill, since the user is allowed to enter their own values? Well, this is because they're completely irrelevant for what this machine calculates. The player could have points into the fire and lightning trees, that's perfectly fine, but for the values this machine computes for that build, the number of points allocated into those skills do not affect anything we're interested in, so the user can just ignore them when entering information regarding their character. We don't even need to account for these relevant skills for level, since we configure level backwards using attribute points instead. So there's a lot of states. The first 9 are for allocating points into auto generation, then most of the rest are for handling calculations, with a few such as Q menu and Q start and Q quit, just handling the flow of the machine from menu to menu. All right, here is my state machine in JFlap. Now this thing looks more complicated than a Path of Exile skill tree. There's a lot of nodes and edges, but I grouped them according to their purpose to help organize the structure of the machine visually. To start, if the user decides to have the machine calculate the build for them, the starting money sign will occur just before the blizzard zeros, because the A will have to be turned into an S so that the machine knows where to start whenever it has to do calculations using that build. So just after Q teleport and Q prereq, or just before Q ice bolt, if the teleport check fails, is where that S will be, the money sign. This is because the success or failure of allocating teleport and the prerequisite skills actually do not affect any future calculations, so there's no need to store them in memory. Also, the route of automatically allocating the best builds will leave some O's and F's in the tape after it's done converting all the S's into meaningful characters, but that's okay. They're just there for helping separate the S's in the game machine, and they'll just be ignored later on. So you'll notice the initial allocation part of the machine that determines the best possible Blizzard Sorceress build at any given level does not add any 7s or 8s to the stack, which represent attribute points allocated to dexterity and energy. So why even include them in the machine? Well, first of all, the reason the most optimal build never includes them for a Blizzard Sorceress. Dexterity affects ability to use certain weapons and chance to block, both of which are useless to a Blizzard Sorceress because they never use those types of weapons, nor do they ever use shields. They're pretty exclusively use staffs. That makes sense, but why not energy, the trait associated with giving mana? Well, quite honestly, the mana that's gained automatically per level up is plenty for what a Blizzard Sorceress requires, given, especially with the skill Warmth, which is included in the prerequisite skills that the player chooses to let the machine allocate their skills for them. Then why are these even part of the machine, you may ask? Well, since the player now has the option to put their own values to calculate stats from, they may not want to follow this logic, and that's perfectly okay. Players are entitled to play however they want play to have most fun. They want to provide the ability to calculate for however they like to play, or even a theoretical scenario. And we still need to include those skills to make sure to actually figure out level accurately. Now, having Q health, mana, and stamina separated into these triangles seems wasteful at first glance. They're off to the right here. That's how you calculate those stats. They're so similar, there must be a way there must be a place for reusability to condense their size and be more efficient, right? Well, after a lot of analysis and time, I found that this is not necessarily the case. The closest solution I came to was to have Q menu break into Q mana, Q stamina, and Q health, depending on the next action indicator, then go and replace all the characters of interest with another character, let's call this character Z, and then have Q 2.2 loop on those Z characters and have the rest go to Q 0.2 in a blank transition state. This would allow me to point all skill-based transitions to the blank state and all attribute-based transitions to the 0.2 state, except for the one of interest, since the one of interest that pointed to a 2.2 state would be replaced by Z's. However, there are 3 issues with this. First, stamina would need its own separate region because it needs a different state that outputs a 1.2 for every point of vitality instead of a 2.2. Second issue is that this method would actually decrease efficiency. Though the state machine would consist of fewer states, this calculation would require going through almost the entire length of the tape 3 times, which is resource inefficient compared to the 2 times required by separating the calculations into 3 separate regions as done. And efficiency is much more important in tape reading than in machine size. To be specific, the machine would have to go all the way to the left to replace each character of interest with a Z, then go almost all the way to the right to output the value to the calculator for each character, then all the way to the left to replace each character with its original value, which leads perfectly into the third issue. There's no way to remember which character to replace all the Z's with to return it to the original, unless another indicator was added to the end of the string, which would require going through the length of the tape again, or separating the states into separate regions, which if we decide to do, we might as well take this design where we only go through the length of the string once to output calculation values, then once more to go back to the hashtag at the beginning of the allocation section of the string. But that's what Q reset does really, is you just it just sends you back to the end of the build, but the beginning of the player commands of what to calculate. Now, another place where it appears efficiency can be improved, but actually cannot. Q reset may initially appear wasteful, as every time we calculate a value by running through the length of the first section of the tape, we have to go all the way back through to the right before we can run to the next one. However, there is no way around this with a Turing machine that does not loop from front to back on the string. The information for what to calculate or do next exists only on the right side of the tape, so the machine has to go all the way back to the right side to see what to do next or look for next. Moving these commands to the left side would not fix the issue, it would just simply reverse which direction the extra run through the tape the machine has to go through goes. Calculating the damage for Blizzard was a fun maneuver. Because the section of the tape being read could come in any order, there had to be a way to keep track of how many points had been placed into Blizzard so far, and whether the character being read was relevant to the calculation or not. Now, the amount added per point is different depending on whether it was the first point to the 7th point added, or the 8th to the 15th point added, or the 16th to anything above point added. So this took 16 states to do. Additionally, there is a buffer state and a synergy state for each of these states. As this is required to hold our place while moving between different kinds of characters. Finally, the starting state for the calculations is just there to prepare the chat box and enter the base value from which the rest are added. In C++, you'll see we use a variable to count this to simulate moving through the number of states, though the real machine doesn't actually have that luxury. So this is QDelete. So QDelete's neat. So first we hit QDelete1, which just moves the read head all the way to the left. And then next is QDelete2, where we delete every character and shift right and then delete the next character until we hit a capital R, which is the original indicator for QDelete, where we stop deleting and go back to the start of the machine. And right after that R would follow like another build, and this would signify the user resetting and putting a different string into the tape, whether by the machine allocating the build itself automatically, or by taking the user input of a custom build. For the purpose of this JFlap, this takes the form of these characters already existing in the tape after the capital R, but in reality, these characters would be fed into the tape of the machine in real time. Also, I could have swapped the two states and deleted each character coming from the left, then just go right through blank spaces until I hit the R, but they're identical in efficiency, and since they both go back and forth the same number of characters, this method just felt cleaner to me, so I chose this one. So I'll show the actual JFlap real quick, especially because it might be a little bit easier to see. This is the JFlap. It's large and complicated. I am already over on time by a lot, so I don't have enough time to do a step-by-step, but I can do a fast run real quick just to show kind of what you would expect. So this tape I'm putting in has a ton of A's or has a ton of S's after an A, so you know it's going to be automatically generated. And there's an R right here, which shows that there's going to be another tape generated afterward. I'll click OK. It goes through over 500 calculations, and I don't think I can scroll to the beginning of this tape, but if I could, you would see that all those S's were translated into zeros and ones. Actually, you can see it in the second part after the reset that happens, and then after each command was processed, it was converted into an X, and then E is where the machine is told that it can close. So, and then here's a C++ implementation. It's kind of difficult to read like this, so I'll just show you the actual program. Once more, you input a string. For example, I'll input this, and when you click enter, it'll tell you what all the skills that you would get based off this, which is all the successes would indicate successes into Blizzard, and the first two into these, then Blizzard, then the F would move on to the next one, which is Ice Bolt, and so on. And all of these at the end, after the hashtag, are the commands down here, which is to calculate mana, health, blizzard damage, ice damage, and then the system closes. So, oh gosh. So I couldn't, I was unable to find any Turing machine designed to make the best Blizzard Sorceress at any given level and calculate all of the Blizzard Sorceress stats. The closest thing I found are the skill tree calculators that show how much damage a skill would deal, which is linked here. Mine is different in that it is engineered towards a specific type of build and calculates many more numbers, such as health, stamina, and mana. All right, thanks, guys. Here's the rest of the citations, and I just want to thank you for watching, and please have a nice break, and I'm excited to see your guys' Turing machines.